So let us discuss the Six Sigma projects in various areas. We already know that Sigma is a statistical concept that represents how much variations there is in a process relative to customer specifications. Sigma value is generally based on the defects per million opportunities, and Six Sigma, which is equivalent to 3.4 defects per million opportunities. Generally, the amount of variation will be too high when the sigma value is low, that is between 0 to 2. It's moderate in the middle, that is between 3 to 5, and very little, that means virtually it will, virtually all outputs meets the customer specifications, that is when the sigma value is very high. Six Sigma is developed by Motorola in 1980s. So the senior executive, the art portrays criticism about the quality in Motorola, made Bill Smith, who is considered as the father of Six Sigma, introduce the quality improvement methodology to Motorola. And Six Sigma that replaced both total quality management and business process management, business process re-engineering. So here we are going to discuss about some of the projects or some of the advantages of using Six Sigma in various areas. For example, like healthcare. So it improves the patient safety, reduces medication errors, reducing the length of stay in the hospital, reducing the risk of infection. Then in finance, improving customer service. Everywhere we can tell, if it is healthcare or finance or IT or any other service industry, any other, we can tell that one is it will improve the customer service. Second, reducing the time taken for processing the payments, reducing the cost of credit card transactions, reducing the amount of time it takes to pay the bills. In manufacturing, again, improving customer care, customer service, improving product design, improving quality control process, reducing lead times for new products, reducing defects in products, reducing scrap rates, reducing maintenance cost. In insurance, reducing the claim adjustment time by 50%, almost half. So reducing the insurance claims processing time by 20%. The claim rejection by 30% reduced. Improved customer service, improving claim handling. So improving the efficiency of claim processing, reducing the cost associated with insurance fraud, reducing the cost of claims processed by 20%. Then comes in construction, improving the quality of construction projects, reducing the time taken for construction projects, reducing in the number of defects of construction projects, improving quality of construction materials, reducing the time taken for building projects, improving quality of concrete, improving safety measures for construction workers, reducing accidents during construction, improving construction quality, reducing delay in construction projects, improving the efficiency of construction process, reducing the cost of construction projects, weld repair rate reduction. Then in education, improving students' performance, reducing dropout rate, reducing the time taken for students to pass the exams, improving teacher effectiveness, ensuring that students are able to perform well on standardized tests, reducing the amount of time it takes for teachers to grade papers, improving students' retention rate, reducing plagiarisms, reducing students' stress levels during exams, hospitality, improving customer service, reducing food waste, reducing the time taken for a guest to check into their rooms, reducing the amount of time it takes to clean the rooms, improving food quality and service standards, reducing customer complaints, reducing the cost of catering services, reducing the amount of time it takes to serve a customer, reducing the time taken by waiters to prepare or serve food. Then in public sector, improving customer service, reducing the time taken for a passport application, the waiting time at immigration counters, the time taken for processing of applications, the waiting time at the airport, the waiting time for passport renewal, improving traffic flow on roads, the quality of water supply, the efficiency of public transport, the effectiveness of government services such as healthcare and education, or healthcare or education, service delivery, environmental sustainability, energy efficiency. Then comes in environment, improving customer service, reducing the time taken for a movie to be released, the amount of time it takes to make a movie, the length of queues at movie theaters, the time it takes for a new album to be released, reducing staff turnover, improving the quality of the entertainment experience. Then in order to find the defects per million opportunities, so we are having some formulas. First, defects per unit, DPU equal to number of defects discovered by number of units produced. So defects per unit, or DPU, equals number of defects discovered divided by number of units produced, and defects per million opportunities, that is DPMO, that is equal to the number of defects discovered divided by opportunities for error into into 10 lakhs. Then to find CP, that is defect rate process capability index, CP, that is equal to upper specification limit minus, that means the difference between upper specification limit and lower specification limit, which is divided by 6 sigma. And CPK, that is estimating the process capability index from sample, that is equal to the minimum of upper specification limits minus mean, X bar stands for mean, divided by 3 sigma, or that is S stands for standard deviation, and mean minus lower specification limit by 3 sigma. So here we are having some problems for identifying the defects per million opportunities, CP, that is defects rate process capability index, and also to estimate the process capability index from a sample, CPK. So in order to stay a minute. So we mentioned about these points, like defects per million opportunities, defects per unit, defects rate process capability index, estimate process capability index from a sample, CPK. Then in order to calculate DPMO, so what exactly we need is the first, determine the total number of units in your sample size, calculate the number of defects, that is the total number of units in your sample size, then number of defects per opportunities per unit, determine the total number of defects in your sample, multiply the number of units in your sample size by the number of defects opportunities in the sample, Then divide the total number of defects in your sample by the number you got from step 4. Multiply your number from step 5 by 10 lakhs to get your DPMO. So next, finding DPMO and process sigma. So here the question is, a laboratory reports 1000 ED stat results in a month, that is a product. 10% or 100 results are not reported out within the specific period of time. The number of opportunities for defects is given as 3. Representing the 3 phases of testing, like that pre-analytical, analytical, and post-analytical. So once if the number of products, defects, and opportunities are known, it is easy for us to find the DPMO, that is defects per millions opportunities, and sigma level can be easily calculated. So the defects per opportunity DPO, which is equal to defects divided by product into opportunities. So defects is 100. The total number of products is 1000, and the opportunities is 3, which is equal to 0.0333, etc. And the defects per million opportunities, we can get it DPO, multiply the DPO, that is defects per opportunity, by 1 million, which is equal to 10 to the power 6, that is equal to 33.33333. So with the sigma table, so for process sigma, once if you have determined the defects per million opportunities, by using the sigma table to find the nearest value for this 33,333, which is equal to 3.3, that the sigma table is being given in the next slide. See here, this is the sigma, this is a sigma table. So here it is, the defects per million opportunities, sigma short term, sigma long term, and yield. See here, in this case we are having, which is almost equivalent or equal to 33,333. Here it is 35,930. So almost, which is equal to 3.3. Then second one, in order to find CPK, another example, food served at a restaurant should be between 38 degrees Celsius and 49 degrees Celsius. That means we got the LSL, that is lower specification limit, and upper specification limit. So the food served at a restaurant should be between 38 degrees Celsius and 49 degrees Celsius when it is delivered to the customer. The process used to keep the food at the correct temperature has a process standard deviation of 2 degrees Celsius. So we got sigma. So the lowest, that is lower specification limit LSL we got, USL upper specification limit we got, standard deviation got, and the mean value for this temperature is 40. Mean value also we got. So find out the CPK, that is process capability index for the process. So in order to identify CP, the defect rate process capability index is UCL minus LSL by 6 sigma, and process capability index is the minimum of USL minus mean by 3 sigma, or mean minus LSL by 3 sigma. So X bar here we mentioned about the mean, and S here we mentioned about the standard deviation from the given problem. From the given problem, it is very clear that the USL is equal to 49 degrees Celsius, LSL is equal to 39 degrees Celsius, standard deviation is 2 degrees Celsius, and mean is 40. For finding CP, USL minus LSL divided by 6 sigma. That is 10 by 12.833. And CPK is the minimum of USL minus mean by 3 sigma or comma mean minus LSL by 3 sigma, which is minimum of 9 by 6, comma 1 by 6. The minimum is 1 by 6, which is equal to 0.166. Therefore, the process capability index is 0.166. So then comes the first sigma, which is equal to 30.85% defect free. Second sigma, 69.146. Third sigma, 93.319. Fourth sigma, 99.379. Five sigma, 99.977. And 6 sigma, which is equal to 99.99966 defects free. And even the last one, that is 7 sigma, which is equal to, so 6 sigma, the defects per million opportunities is 3.4, and the accuracy is 99.99966, whereas that of the new one, that is 7 sigma, which is equal to, which is 0.019 defects per million opportunities, and the defects free is around 99.99998. That's all.